Assalamualaikum, and I think good afternoon dah kita ni kan. First of all, I would like to apologize for some mistakes in the scheduling yesterday because I thought I was supposed to present today. Tak apa pun, I would like to thanks lah Green Tech Malaysia for rescheduling today. If you can see at my slide, actually this was supposed to be presented by Encik Zaini, one of our what do you call it, committee members. Uh, the topic of our my presentation today is basically energy management, how to sustain good energy use through energy management system in buildings. Next, if you can see the demand for energy in buildings is projected to increase, and the biggest what do you call it uh, portion is basically from electricity. Next, uh, this is what we have to overall. If you look at the overall energy use, actually building itself is not really that big, but it has a huge demand on energy. If you look at the power at the bottom there in the blues, so this is why it is important for energy building owners to really focus on energy use in order to help them to reduce the carbon footprint. Next. When we talk about energy in buildings, the first thing that we will most likely think about is energy efficiency. Actually, energy efficiency is just a portion of energy management. I was quite attracted to the quote provided by Mr. C earlier on, whereby he was saying that IoT turns data into information, and then information is then turned into insight. But with energy management, we use this data, information, and insight into some action that we can implement. So it is all about capturing data, using these informations to drive down our energy costs, and at the same time, it will help reduce our carbon footprint. Next. Without an effective energy management system, uh, inefficiencies in building operation can go unnoticed. How many times can we see lights being left on, even AHU being left on overnight in buildings because nobody is focusing on energy as something that they can manage. Okay, without energy effective management system, lost opportunity to improve energy use and reduce carbon emission may not be acted upon. Unnecessary energy expenditures erodes our profits and performance. Next. These are examples of potential energy savings at buildings. As was presented earlier also by Mr. C, and I think in Cik Zul as well, the biggest portions of energy use in building is of course in cooling, which can reach up to about 60%. And possibly the next one is in lighting, and the rest are in either ventilations or other uses. Next. This is an example of energy conservation program implemented in Malaysia. One is in a private commercial complex where they look at losses in the transformer, they address the cooling system, they address the lighting system, and also they manage the maximum demands of the electricity use. This shopping mall are able to save in excess of about 1.5 million per year ringgit. In the warehouse, they just replace the lights using LED lights. They were able to save close to 100 million in a year. Okay, next. Efficient energy efficient technologies uh, are the key components in an energy management system. Okay, when you manage energy well, you have informations about your data use. You will then be able to have a good benchmark about where you are against others. For building, the typical benchmark is of course the BEI, Building Energy Index. And with this, you are able to plan and do uh, improvement Then subsequently after that, you check and monitor whether those improvements are achieved or not. And of course, then you will act on it. Basically, energy management is basically a PDCA cycle, as you can see here. Next. These are some examples of benchmarks of buildings, low BI building in Malaysia. It started in 2004 with the then Ministry of Energy Office, whereby they were able to get the BI to about 114 kilowatt hour per meter square per year. This was then overtaken by green tech buildings, which were able to reach about 30 kilowatt hour per meter square per year. And the next building is basically the SD building, the diamond buildings, where the BI is in the region about 63 kilowatt hour per year. Next. What are energy management standards and what is energy management? Energy management are activities to ensure efficient use of energy in an organization. Basically, it's all about the day-to-day activities addressing energy use. We have standards. One of the such standard is ISO 50001 standards, and the other one is the IMAS standards, where they provide systematic approach for management of energy use. The process involved include ensuring that energy is used efficiently, adopting a system to achieve the desired result. But the key things about energy management is not so much about equipment, but it's about getting people involved and making them aware of what they can do towards reducing the energy use and reducing the carbon footprint of an organization. Next. These are some of the lists of the ISO related energy system. Uh, these systems are a good guides for anyone who want to start to look at how they can implement energy management, energy audits, and what have you, and others that is associated with energy management system. Next. Uh, the 50001 has been adopted quite well all over the world. It's jumped tremendously from 2011 to about 12,000 registration globally. It has been recorded to be able to save up to 26% of organization savings, and the average savings is in the region about US dollar 1.2 million to most of these global facilities that are practicing energy management system under ISO 50001. Next. So, what is it all about? Okay, basically, it's all about having a management commitment to implement and to manage energy as something that can be managed. Okay, how do we normally manage energy in Malaysia? I think most facilities that do not have this system in place probably are looking at their budget. If the bill from TNB is within the budget, uh, the bosses are quite happy to just sign the check to pay the bill and thinks of energy as something that is a fixed cost. But in reality, quite a big portions of energy cost is manageable. So the management need to have commitment put in place. With this, they will then have to have a policies about how they're going to use energy, and then they will have to plan, do energy survey and assessment of where and how they use energy, set up their baseline, identify their benchmark where they are in respect to energy use, and then with these informations, they will start to implement the how they use energy properly, and they need to continuously uh, evaluate their performance. From these evaluations, then the management might have to need to review and look at how things need to be addressed, either in terms of additional awareness, additional budget to improve their energy performance. If you can see on the slides, basically The top part of the slides are where the managements are mentally involved. These are some things that is not a day-to-day activities of energy management. It probably be something that you look at maybe every quarter or every 6 yearly. But at the bottom part is where you manage your energy on a day-to-day basis. You use information either through IoTs, through your online meters, to give you a clear idea of how you use energy, whether you're performing well or not. So energy management is about doing this on a regular basis. Next. Who are the key players? The top management is the key. If your top management is not committed to energy management, I think no, you might as well forget about it. The top management has to be fully committed, and they have to understand that energy is something that can manage. The top management will need a qualified energy manager, or at least a knowledgeable energy manager, to assist them, and the rest of the teams through the organizations are involved. As long as you're still using energy, you are involved in the whole process about energy management. Next. Okay, these are some global stories, success stories on organizations that implemented ISO 50001. As you can see from the top, uh, they have been able to save the London School of Economics have been able to save 10% of the energy use. TNT in Chile, they are saving in excess of 262 US dollar per year in saving. And at the bottom, they are able to, this company was, I don't know this company, Schneider Electrics, uh, were able to save 25,000 megawatt hour. So using energy management, it is achievable to save energy and maintain your saving consistently. Next. Uh, Again, this is basically what is a key component about energy management. It's all about data, because you are using your data to understand of how and where you use energy, and acting on this data to help you reduce, come up with plans and activities to help you reduce your energy use. Next. Okay, when it comes to determining current energy performance, it's often required the technical study. This will involve equipment system assessment, which can of course be done internally or with external parties through your equipment suppliers and things like that. You can also do a basic walkthrough assessment through observations of your uh, operational and maintenance checking. This can be done internally. Of course, one of the key things is about your energy audit. Energy audit is basically an assessment of how and where you use energy. Often this is done by external parties that will come up with your recommendations of how to save energy in your organization. Next. Uh, the following slides are overview of common areas for energy saving measures in buildings. Next. Uh, Air conditioning, as was mentioned earlier, this is where almost 60%, up to 60% of your energy is being used. Here, you can look at chill water temperatures. Mr. C, companies' monitoring system will be very useful in addressing all of this. You look at the opportunity of part load operations and humidity control. Is your system sized properly? Are the fan volumes controlled well? Room air distributions, which is need to be addressed to. Next. Uh, Cooling system, again. You need to reduce the heat gain if possible. What are the control set points? These are the questions that you need to address when you look at addressing cooling requirement. What is your control strategies? What are there manually overrides being done? Are windows being left open? Is the heating on the same time? How are the occupants dressed? And maybe there are some of them are too cold that they have to wear gloves in the office. Don't be surprised. I've seen this in some buildings in Putrajaya. The operation of centralized chiller system are also critical. Is it running when not required? Is it running excessively? Is it constantly cycling on and off? Is there a conflict between cooling requirement and cooling systems? These are all the questions that need to be addressed when you are trying to understand how your chiller system works. Next. With the other motor-driven things, you look at whether it is possible to put in place variable speed drives to control the speeds of your motor, especially when the motor either oversized or the load is not constant. Because by putting in a VSD system, you can reduce consumption between 20 to 70% of its actual use. Also, the VSD acts as a soft start for your AC motor. Next. In the ventilation system, you look at whether it is properly maintained. Uh, is there any potential for heat recovery too? Because chiller system provides excess heat that can be used to heat up your water, that can be used for cleaning either in your kitchens, or if there is a shower system in your buildings that can be used for shower. Can the system be used for night purging or pre-cooling? That is when there's also a good option. Is there any so that at night your building is cool using the cool air outside, you don't have to the demand for the whole building in the next day will be much lower. Is there any natural ventilation being used? This is an option, and of course a requirement for certain green building standard. Next. Lighting, everybody is aware about lighting now. The LED is so much more cheaper than and so much the same price as conventional lighting. This is almost like a no-brainer. So companies should start to look at implementing LED lighting, either by first through replacement of your conventional light as they fail, and so forth. Next. Effective control basically is important, because control is part of IoT things, where you have everything in front of you, you're able to manage. When everything is in a manual form, people tend to ignore. People assume that you put a timer, the timer works for life. Timer doesn't work for life. We have done audits whereby the facility teams are so confident that they have switched off everything at night. But when we went to the site at night, we noticed that the timer controls are faulty. So there are equipments that are being left on, which everybody assume it is switch off automatically by the timer. So it is important to make sure that all your sensors are operational, and these are part of the day-to-day activities of energy management, which has an impact on a maintenance requirement, as well as was mentioned by Mr. C earlier on this morning. Next. There are many type of sensors, of course. You can use temperature sensors, humidity sensors, carbon dioxide sensors, movement sensors that can all help to be for you to be able to control your building optimally, so that you do not use as much energy as required. Next. This is an example of energy retrofit that was done by one of our members. Here, this site has three chillers, two 1,500 ton and one 800 ton. The two chillers was running, the one of the 1,500 and the 800, and the total installed capacity was 23,000. Actually, the measured capacity during the audit was only at 1,800, with effective efficiency of about 1.2 kilowatt per ton. The ESCOs that look at this project make recommendations. Come on, next. Next slide, please. By installing 3 new chillers and removing one of the 1,500 chillers. Now the installed capacity has increased to 24,000, but while the actual running requirement has be able to be addressed either between 1,800 or 2,400 tons. The effective new efficiency was 0.7 kilowatt per ton. One of the key things that have also been done was to eliminate the primary pump in front of the at the chiller end. So this has provided a tremendous saving to this site. Next. So when you want to implement energy efficiencies, when you want to implement any large scale investment projects, the key things that are you that the three key things that you normally think of are the technical viability of the projects, and of course the most important thing is the financial viability. Whether you know when you invest in it, how soon you get your money back, and of course a lot of people do not think about the third one, which is the sustainability of the plan. Technical viability, you can source out, get people to come and provide you expertise. Financial viabilities are basically the potential of the savings that you get. This can you know these some things are you can do internal assessment of it. But in order to maintain that these projects, whatever that you do, continue and is maintained well, you need a good system to continuously monitor its performance, which is through energy management. Next. Uh, Here, I would just like to share some ideas about potential investment for energy-related projects. There are actually normally three ways to finance projects. One is internal cash, of course, which you can do. The other one is, of course, you can go through loan, grant, or leasing. Government sometimes do provide on and off grants, as far as was mentioned earlier by Encik Zul. And the third way is, of course, by doing an external party or third party to do an energy performance contract on any retrofit at your facilities. Typically in Malaysia, for buildings, there have been a lot of EPCs based on lighting, which is a total replacement of lighting to LEDs. And a lot of as well, they are doing either energy performance contracting at the HVAC system, at the cooling system, either through proper monitorings and management of the system itself or through replacement of some key components in the cooling system. Next. So what next? Basically, energy management is important. If you want to have a sustainable energy management system in place, you have to have your top management commitment. Carry out the program. We at MESCOs can assist you to do the audit, to do the planning, carry out the actual recommendations, your action plan on how to reduce your energy savings. Do not forget the people because they are the energy users. So they are the first people that you should engage if you need to make your energy management a success. And then a continuous reporting and reviewing with the good support of your top management will ensure that you will succeed in your energy management. Next, I think that's the end. Thank you very much.